Good afternoon, everybody. It is Tuesday, April 7th. Today we're going to continue doing solving systems using substitution. And so we have two equations since it's a system. And notice that we have one where that x is isolated. X is equal to 2y minus 4. So just like if x is equal to 7, if it told us something like x is equal to 7, and we would take that 7 and put it in for this x, we're going to do exactly the same thing here. I'm going to take what x is equal to, which is this quantity 2y minus 4, and I'm going to put it in for that x right there. And it's going to give me 2y minus 4 plus 2y is equal to 8. Okay? And once I do that, it's just going to give me a multi-step equation. And so I don't have any distributive this time, but I do have two variables on the same side. So I'm going to go ahead and combine that 2y plus that 2y. And that's going to give me 4y minus 4 is equal to 8. And so now it's just a little two-step equation. I can't do anything with this y right now because it's all wrapped up with that 4y. So I know that I need to get rid of that minus 4, so I need to add 4 to both sides because we do the opposite to get rid of it. And we have to keep it balanced, so we do it to both sides. And I'm going to cancel this, and it's going to give me 4y is equal to 8 plus 4 is 12. And now I'm multiplying by 4, so I'm going to do the opposite, which is divide by 4, and I'm going to do it to both sides. And I'm going to be left with y is equal to, and 12 divided by 4 is 3. So I know that my y value in my ordered pair that is a solution is 3. So I'm going to come over here, and I need to figure out my x. So I'm just going to plug that y in, that 3 in for that y right there. And I'm going to do x is equal to 2 times 3 minus 4. So x is equal to 2 times 3 is 6 minus 4. And x is equal to 2. So the ordered pair that is a solution for the system that works for both of these equations is 2, 3. And we talked about how if we were to graph it, if we were to use the method of graphing, that's where those two lines would intersect. They would intersect at the point 2, 3 in that first quadrant. So if you check it, x is 2, y is 3, 2 times 3 is 6, plus 2 is 8, so it works for that one. X is 2, y is 3, 2 times 3 is 6, minus 4 is 2, so it works for that equation. Okay, so let's try another one. Down here, we have x isolated right here. X is equal to 3y minus 6. And our other equation in our system is 2x minus y. So I'm going to take x is equal to 3y minus 6, because that's what x is equal to, and I'm going to plug it in over here into x, just like I would if it was a number. And this time I'm going to need parentheses because x does have a coefficient with it, so I am going to use that distributive property. So it's going to be 2 times the quantity 3y minus 6 minus y is equal to 3. So I need to use distributive. Make sure you distribute all the way. Remember, that's one of the little tiny errors that we make. 2 times 3y is going to give me 6y. Oops. 2 times negative 6 is going to give me negative 12. Watch those signs. That's another one of our little mistakes that we make all the time. We have to distribute all the way, and we have to make sure that we pay attention to the signs. We're going to have that minus y equals 3. Okay. We did distributive. Our next step is we combine what we can combine before we start moving across the equal. And I can do 6y minus y. And that's just going to give me 5y or minus 12 is equal to 3. I can't do anything to that y yet because I got to get rid of the outside stuff. So I'm going to get rid of that minus 12 by adding 12 opposite and both sides. Keep it balanced. 5y That's going to cancel out. And it's going to leave me with 15. And then I'm going to divide by 5 to get that y by itself. And y is going to equal 3. So I know that in my solution set, the y is equal to 3. So I'm going to come over here and I'm going to put that right there. Okay? Now I need to know what the x is, so I'm just going to plug it into where x is already isolated. That way I have a little bit less work to do. And I'm going to do 3 times 3, because my y was 3, minus 6. And so x is equal to 9 minus 6. And 9 minus 6 is 3. So my solution set for this system, or where it would intersect if we were going to graph it, the point that works for both of them is 3, 3. And we can check it. 3 is equal to, well, 3 times 3 for y is 9 minus 6. So that works out. Come over here. 2 times 3 is 6. 6 minus the 3 for the y is 3. So it works for that one also. So it's a solution for both of the equations in the system. So whatever we say our solution is, it has to work for every single equation. We've only been working systems that have 2, but you could have systems that have infinite numbers of equations, and they would have to work for, it would have to work for every single one of them. Okay? So tomorrow we'll do some more work with solving systems with substitution. We're going to look at what happens when you don't have something isolated. What do you do then? And so that will be tomorrow. I love y'all. I miss y'all. Take care and be safe, and hope to see you soon.